Hey kids, it's time for another episode of Games I Should Have Definitely Bought! Today at the Ann Arbor Pinball Museum, we're talking about the Pacific Amusement NeonTact pinball machine from 1935. The only pinball that I know of that has neon lights integrated into the gameplay. It's not just some aesthetics, it's actually part of the gameplay. And this game has its original neon. It has not been replaced. So this glass tubing in this game is nearly 100 years old and it still works like a champ. Why you dirty bastard? A quick rundown on the rules. Here's the scorecard. Basically, what you're trying to do is spell out 2, 5, 10, or 20, and then you win free games, or you get paid off by the bartender. And the neat thing about this game is that this could be in the corner, and the bartender could see it from across the room exactly what you have spelled out here to get the appropriate number of free games. Now, I must admit, I have primed the game and put balls in all the letter holes to light it all up, but normally I don't think you would ever get every letter lit, but I wanted to show you what it looked like. Now, the other important part of the gameplay is this igniter right here. You have to sink a ball into the igniter or you don't get any letters. Whoa, 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 whoa. So here, let me show you. If I pull the igniter out, the ball out, look, you lose all the neon. So it doesn't matter if you have all the balls in there, you're going to lose and not get any payout. And look here, if I pull my E up, you can see the E, how when I move this ball up, each one of these holes is a letter. This is T1, so this is the first T. And then this is V in 5. So that's the whole point of this game.
I'm measuring the capacitor voltage and it's around...
And the other neat thing is this thing, the ball bounce mechanism. There is a little knob right here that you turn and you can move the ball influencer to any one of the spots. So when the ball comes off the shooter, it hits this key. See, these two are raised. This one is not. But you can see now green is lit and this bar is down. Likewise, there's one over here. If you have, here's the blue. If you have them all up, this one lights. That way the ball can come around the whole thing and go into the V hole. And the whole purpose of this, they show you with the arrows, is if you get the bounce back, you're trying to get the igniter. So you basically want to start the game with the green lit and then move to maybe B to get the F, and then the red to get the E, and then maybe come up here and get the V to spell whatever letters you want. You have some influence over the gameplay.
Outputs an AC voltage. You need a full bridge rectifier first to convert it into DC.
Little gameplay. I've put my nickel in and reset the game. You hear the click? That's the timer. It has like a 5 or 10 minute timer because it doesn't want to leave the neon on apparently all the time. I have my gate set to green because I want to try and bounce the ball off the green gate and get it into the igniter. That's really the first thing you want to try and accomplish. Yes, hit it. So I hit the igniter hole, which is exactly what I want to do. Now this is on. That means any of these letters are hot. So now I probably don't want the green anymore. I'm going to let's move to the blue and try and get it up to F. We'll try and get 5. Nailed it. Oh my God. And notice that this is blue. Okay, so you get two colors in this game, blue and red. Blue is argon-filled neon, and red is neon gas-filled neon tubes. All right, so now we want to try and get our next letter. Maybe we'll go off red and try and get the E. Let's try that. Nailed it! Yeah! Okay, so now I think what I want to try and get is the V. So we're going to turn our knob and turn this light on, which means all the gates are up. Nailed it! All right, so now all I need is an I, and I'll win 5 free games. Now, the I is tricky. I still want to go with this and try and bring the ball up here and droop down into there. Got a W. Maybe we should go for the 2. This I is going to be tricky. Go. Nailed it! Bartender, 5 credits. All right, so let's see if I can get the T and the O, and then I'll have 2 and 5, and it'll have to pay me 7 games, or 7 credits. Whoa, baby! Nailed it! Now, so how do we get the O? Well, to be honest with you, I'm not sure you can even get the O. I mean, look at it. What the hell? All right, so I'm just going to cheat. Look. Bartender! 2, 5. You owe me 7 credits. Game over. Pay up, dude! For now, it's nerd time. I've shown you the gameplay. Now I want to show you how this game works and some of the modifications I made to the game to make it a little more robust.
Where are they? I think they're talking about us. No way.
So the big question is, this game was originally running on 6 volts worth of 1.5 volt dry cell batteries back in 1935. How did they get 6 volt worth of battery power to turn on neon? Neon is high voltage, and I mean really high voltage, like 3,000 to 10,000 volts worth of power. Low current, like 30 milliamps, but it's still a lot of voltage. So how do you get 6 volts up to thousands of volts? Well, the answer is use an ignition coil from a Model T. Okay, so that's exactly what they did, and that ignition coil is called a trembler coil or a buzz coil. And I'm going to show you how that works and what I did to actually retrofit that with a more modern neon transformer. From a power and safety point of view, it was, I think, a smart move.
Oh, I can feel my hair rising. Ow! Something zapped me.
Let's talk about our trembler coil or buzz coil. It has a neat little top that slides off to reveal the potted material inside. And this is like a black tar. So you can kind of see there's 2 chunks here. This is the transformer, the primary and secondary winding. And then there's a piece of glass insulator across here. And then this long thing here, which you can see in the impression, is the capacitor or condenser. And if we look on this side, you can see it was manufactured by KW Ignition out of Cleveland. So this is the exact box used in Model T ignition coils. But I want to show you how this thing works. So what I have is I have a power supply here with 6 volts that's going to our T2 lead and ground. And then I have a small neon light right here. This is just a piece of neon because I like neon. I have a lot of it, and I use this to test things. So it's connected to ground to one side, and then the output is T1.
So don't do this at home. Now you have high voltage.
And on this side is the vibration switch, which we have to gap at 30 thousandths, and you can see as this transformer pulls in, it pulls this switch in, which turns the transformer off, and then it lets this back, makes contact again, and then pulls it back. It's kind of like how a bell would work over and over and over, and you'll hear the buzz, hence the name trembler or buzz coil. So let me turn on my power supply, and you can see how this thing all lights up. So you can hear it. And you might even see a spark. See the spark? Yeah, that's your buzz coil with that vibration switch. And if you look at the neon, you can see it's not a strong neon pulse. You can see it kind of flash on and off. It's not really how neon lamps should work, but again, you're using 6 volts going to a transformer to bump up the voltage.
Put of my auto transformer, I should.
Now we're going to show you the approach I took in modifying my game. I am using a Neon Pro transformer, but this isn't the actual one I'm using. This is a 12 volt Neon Pro, where it takes 12 volts from my power supply and then bumps it up actually to 7,500 volts at 30 milliamps to light this tube. And I will turn this on now without the trembler coil, and you can see and hear the difference that a modern transformer produces power for neon. So you can see the tube is much brighter, it's not flickering, and we have no noise. And because this has what's known as GTO wires, these are basically silicone-based wires, it is in theory safer. It's also GFCI, meaning that if this somehow senses somebody touching the high voltage, it'll automatically power this transformer down so you don't get shocked.
The higher the amplitude, like this. What the are you doing?
This style transformer, this GFCI style transformer, was required by law in the early 2000s for all neon applications. They all have to use some sort of interruptible transformer. But you can see how nice this tube looks compared to the trembler coil, the buzz box. This is just a much better look. And that's why I abandoned this and went to a real transformer for my game.
Let's play Pink Panther.
Of course, the other advantage to using the transformer over the trembler coil is that you just get more consistent power if all the neon numbers and letters are lit up. This just does not have enough output to really light all the letters in the game all at once. I mean, it can do 4 letters, but once you get more than 4 letters, they really start to get dim and hard to see, where using an actual modern Neon Pro transformer, I can light everything, including the ignition arch, and it looks just bloody great.
What's up with my circuits and all this smoke?
So let me show you the inside here and the modifications that I did. I've removed the lower panel that catches the balls. And here is the trembler coil mounted on springs.
Something tells me this is not the right setup, but whatever.
So this is completely disconnected. You can see I got my wiring down here with a connector. You could hook it back up, but right now I am not using it because instead I installed a Neon Pro 8,000 volt transformer, and then I put in a 120 volt plug for the transformer. And then this is a power supply that supplies 6, 12, and 24 volts, but I am really only using the 6 volts. I use this transformer, this switching power supply, because I could monkey around with the voltages. I tried using, this was designed, the trembler coil was designed for 6 volts, but I pumped it up to 12 volts and actually was able to get more letters to light up. It did output more, but I didn't take it to 24. It just, this whole thing with how this vibration switch works, it just, the whole thing just bloody scared me.
You can see it still sparks. Let's try it out. What the f?
Now you will notice I added a bunch of connectors. And the reason why I did that is there was no easy way for me to remove the playfield completely from the game. So I added some more modern Molex connectors so I can unplug the playfield and just take it right out of the game, which is good for serviceability. It really helped me too when I was working on getting out everything wired up and trying to figure all this out.
And each pair is attached to one of these cables, which we can plug them into the wall power plug. And 1, 2, 3, 4.
Here's the back of the back box, and you can see the neon tubes and how they're labeled from 1 to 11. And the way this works is each connection goes to the playfield to basically short out a tube so that it won't turn on until a ball falls into one of these holes and actually opens this switch for the W, which then electricity takes the path of least resistance. So it's going through this switch, shorting out the tube, but when a ball goes in there and the switch opens up, then it forces the power to light the appropriate tube.
Unplug, damn it.
So if you wanted to test this, and this is what I did when I was trying out different transformers, is I would just hook my transformer, I would disconnect the playfield completely. Since I have a plug, that's easy to do. And then you could run a neon from this outside run here to this outside run here on the 1 and 11, and it would light all the letters up, as you can see in this picture. You can also see that I've tried a couple different transformers. This one I'm showing you now didn't have enough power. This was actually the 12-volt transformer. It just didn't have enough power. You could see the letters in the center were not very bright.
So I would never touch any high voltage with a 100-mile long metal pole. Let's look at the spark some more.
There you have it. The Pamco, or otherwise known as Pacific Amusement Manufacturing of Los Angeles, the Pamco NeonTact 1935 pinball machine. Perhaps the coolest pinball machine of all times, and it lives at the Ann Arbor Pinball Museum. Thanks!